Hi everybody, Mr. Long here. We're going to do a screencast, or I'm going to do a screencast on linear relationships, so lines, so constant rates. So in this case, we're going to go to the scales example, and we're going to look at scales and try and write some equations about scales and interpret those equations and see what they mean to real life. So the nice thing about this is that the only boxes that you'll actually enter numbers in are already highlighted in yellow. So if it's anything else, you won't enter a number in, okay? You won't enter a number in. And you're working here with a spreadsheet, which is actually kind of good to get used to using. You won't press a lot of different buttons. You might do file right here, and then save as, or make a copy, put your name in it, something like that, although I don't even know if you'll need to do that. It does automatically save for you. And so anyway, you're gonna, as we go through this, you'll see. So the only button you'll be pressing is this one here, which I like up in these buttons. The only one you'll have to press is text color. If something happens that you don't like say you put a number in the wrong box, you can just go up here to this arrow and hit undo. Okay, so you just hit undo, and then that will do it. So for example, I put a 6 here. I didn't want to have a 6 here. I go back and I press undo. Okay, so I just want to go over this whole idea of the linear relationship. So think of, we're putting candies on a scale, and there's two scales possible. One scale does not have a container. One scale has a container. So I want you to think about, if you took all the candies off this scale, what would this scale weigh? On the other hand, if you took all the candies off this scale and left the container on there, would there still be a weight on it? So with 0 candies, would this scale measure a weight? What about this scale? Would this scale measure a weight? Okay, so you're going to have to think about that. So here we go. So here's our first scale number 1. You can see right there. And it says make the initial value or weight in the table red. Okay, so that's the first thing we want to do. So what's the initial weight of the table? Or sorry, of the scale? Well, this says if there's 0 candies, that's the initial moment, right? That's before you've put any candies on the scale. So what's the weight? So it looks like it's 18. So what you do is highlight that cell. You see the little blue around that, and you go up here and you press the A button, and that changes. You can change it to red. So now we can remember that the initial value for that one is red. Okay, the next thing we want to do in A is do the change in candies and the change in weight. So it looks like the number of candies. So we start with 0 candies, and then we put 5 more candies on. So the number of candies that increased by 5. That's kind of obvious. Now the weight, though, how do we do that? When we had 0 candies on the scale, it weighed 18 grams. After 5 candies, the total weight on the scale, including a container if there was one, was 38. So 5 candies, an increase of 5 candies, how much did that cause the scale to increase by in weight? We went from 18 to 38. So you would use your phone as a calculator or something, and you'd have to do 38 minus 18. Okay, 38 minus 18, and that would be 20. Okay, so the change in candies is 5. The corresponding change in weight is 20. That's A. Now let's go to B down below here. Based on the initial weight in the table above, select the correct type of scale. So is it this type of scale that has no container, or is it this type of scale that has a container? Well, if you notice, that's got 18 grams on it when there's no candies. Is it possible that it's this one? If I swept all 4 of those candies off the scale, what would the scale read? It would read 0. What about this one? If I swept all 4 candies off, what would it read? Well, it would read whatever the weight is of the container. So since this is not 0, to me, since the initial weight is not 0, it looks like this. So this time I'm going to select, see what this little arrow is? You hit that, and we're going to say correct scale. So now we know this is the correct scale. Okay? Now we're going to go over here to C. Now we want to find the rate. And the rate is the change in weight divided by the change in candies. Okay? We also call it rise over run. But basically what we're trying to do is get a rate. How many grams is there per candy, right? How much does each candy weigh? So if I look at this, what was the change in weight? Well, the change in weight was 20 grams. So I go in there and I type over top of that one a 20. Now, when the weight changed by 20 grams, how many candies did it change by? It changed by 5. So I go over here and I put a 5. Now, you can do this in your head or you can use your calculator. So how many times does 5 go into 20? We do 20 divided by 5. And the answer here, again, I can fill in there. It's 4 grams for every candy. Now I need to write the equation. So let's think about this. What's the initial value or initial weight of that scale? Well, it's the weight of the container, and the container weighs 18 because 0 candies weigh 18. So that's going to be 18. And then plus, because each candy makes it increase, and how much does it increase by? 4. Right? Remember, rate repeats. It's 4 grams for every candy. So if you think of these, if we look down at this scale, that would mean that candy is 4, whoops, over the wrong scale. This candy is 4, this candy is 4, this candy is 4, this candy is 4. So rate repeats, and that's why it's multiplication. 4 multiplied by the number of candies. And it starts at 18, because you only get the container once. Okay, you get the container once, but the number of candies is always increasing. So that's repeated adding, which we know is multiplying. All right, now I need to solve the equation. The last thing is to solve the equation for the question mark in the table. So I go up to the table and I look at that and I see that I don't know how many candies there is when the total weight, that includes the scale, is 66 grams. Okay, so the weight is 66, the unknown is the number of candies. So I need to put something in that box there because it's yellow. What am I going to put in that box? Well, it says look in the table and the weight is 66. So I put a 66 there. Okay, now I need to do these ones over here. So I just move back and forth, right, with your mouse or with your trackpad or whatever it is. So now I have to solve this equation. So the first line I look at is this one. So I want to get 4n all by itself. So the first thing I have to remove is 18. Now when there's no sign in front of the 18, is that positive 18 or negative 18? And what is that 18? That's the container. So I need to dump the candies out on the scale and take the scale right off. Take the container right off the scale. So how much do I need to take off both sides? Because whatever you do to one side, you have to do to the other with an equation. So then I would subtract 18 off each side. Now if I do that, look at that, that's 0. That means the container is gone. The only thing I have left now are n candies, and they're 4 grams per candy. And that has a weight of 48. So this says 4 multiplied by n. What's the opposite of multiplying by 4? Dividing by 4. So look at that. 1n, 1 candy, n is the number of candies, weighs 12 grams. Okay? So if the weight on the scale is 66 grams, which there was, right? 66, then there had to be 12 candies. Okay, and they're 4 grams each. All right, folks, that's how you do that. Let's look at the second one. I know this is a long screencast, but let's look at the second one. The second one is this one here. So look at this. At the start, there are 0 candies, and look at the mass, the grams, the weight. It's 0. So there are no candies. And when there's no candies, there's no mass. Which scenario is it? Scale here or the scale here? Think about it. If you have no candies on your scale, this scale weighs 0. Well, can it have a container on it then? I don't think so. So to me, it looks like the one on the left is the correct scale. So I just mark that as the correct scale. Okay, so now let's go over to this one. Let's look at the rate. Let's look at, oh, before I do that, I was supposed to do the, I'm supposed to do lots of stuff. I'm supposed to mark the initial value in red. Text color red. So there's the initial value, 0 grams. So if there's 0 candies, the scale weighs 0 grams. All right, now I'm supposed to do the change in candies and the change in weight. Well, look at this. From 0 to 4 is an increase of 4 candies. From 0 to 24, well, I think we know that that's an increase of 24 grams. So 4 extra candies means 24 extra grams. Let's do rate. The change in weight was 24 grams, and that was in 4 candies. Now I have to use my calculator. 24 divided by 4. That is 6. So every candy weighs 6 grams. What's the equation? Well, what's the initial value? How much does that, if I have 0 candies on, how many grams is it? Well, it's also 0, so I put in a 0 there. 0 grams to start because there's no container, plus 6 grams per candy. All right, then it says solve the equation to figure out the question mark in the table. Again, there's the question mark. So it says when there is 78 grams. Okay, so how many candies are there if there's 78 grams? So I have to type in 78 there. Now, it's already 0 grams here because there's no container. So I don't need to subtract anything. In fact, I need to put a 0 here because I'm not subtracting anything. And now I've got 78 grams, and the only weight is 6 grams per candy times by the number of candies, because there's no container. Well, what do I need to divide both sides by then? That says 6 multiplied by n, so I need to divide by 6. Well, look at that. There are 13 candies on the scale. Okay, so if the weight on the scale is 78 grams, there must be 13 candies. And we're done. Okay, folks, we're done. All right, so now what you should try and do is redo 1 and 2. 1 and 2 are going to be the same as what was in the video. And then you're going to do 3, 4, 5, 6. Okay, folks, good luck, and make sure you submit when you're done.